Before we talk about galaxy clusters, and yes, we are really getting out into the universe now, out into the deeper waters of the cosmos, which is exciting. But we need to talk a little bit about how we know distances to galaxies, distant galaxies, which means we need a new standard candle. We just got through talking about variable stars, RR Lyrae, Cepheid variables, blinking stars, which are extremely useful, but they're limited in their range. Cepheids can go to nearby galaxies. We need other standard candles to go further. Now, we've mentioned briefly type 1 supernovae, and I'll come back to those. But for this chapter, we also want to mention the Tully-Fisher relationship, because what we can do, instead of just comparing individual stars and using the inverse square law, we can actually compare entire galaxies. I like to say that comparing stars with the inverse square law is like comparing light bulbs. And to make it fair, you have to make sure you're comparing a 60-watt bulb with a 60-watt bulb, that the luminosity is the same. Well, if you're comparing entire galaxies, I like to say that we're doing chandeliers instead of individual light bulbs. So how do you know that one chandelier puts out the same amount of light as another? How do you know that one galaxy is the same as another? Well, that's where the Tully-Fisher relation comes in. It turns out that there's a correlation between how fast a galaxy rotates and its luminosity. Now, at first glance, those two things don't seem to be related, how fast it spins and how much light it puts off, and they're not directly related. But there is an underlying connection, and that underlying connection is mass. You see, the rotation of the galaxy depends on gravity, and gravity depends on mass. By the same token, the mass of a galaxy, much of it is due to stars, and the number of stars determines the luminosity. So mass affects luminosity, and mass affects rotation. So they're kind of cousins to each other. They are related somewhat. Now, is this a very accurate method? Well, no, probably not. But we basically find two galaxies that are at the same rotation, and we assume that they put out about the same amount of light. That may not be a great assumption, but that's what allows us to compare galaxy to galaxy and use the inverse square law to find the distance to more distant galaxies. So let's add that in to our distance ladder. Let's go up the ladder here. Right in our backyard, we can use radar to bounce off, or lasers to bounce off moons and planets. In our stellar neighborhood, we can use the parallax shift. Now, that's a very precise instrument. Very accurate. But unfortunately, it's limited to a few hundred light years out. I'm going to skip up here to variable stars. Now, the first type were the RR Lyraes. They're good for distances far within our galaxy. So like globular clusters that are part of our galaxy but far away within the galaxy. But even brighter than RR Lyraes are Cepheid variables. And the big thing about Cepheids is they can be seen in nearby galaxies, such as Andromeda. So the Cepheids then can be used for nearby galaxies, but when a galaxy gets far enough away that you can't see the Cepheids anymore, that's when you resort to Tully-Fisher. Now, at this point, we're getting to some pretty blunt instruments, okay? The inaccuracies are growing here, but now we can compare galaxy to galaxy and try to estimate distances that way. And then for the farthest reaches of the universe, that's when you turn to the type 1 supernovae. And we make the assumption that all type 1 supernovae are about the same luminosity. Why? Because a type 1 is a white dwarf exploding. And all white dwarfs explode when they get to the Chandrasekhar limit of 1.4 solar masses. So we kind of make the assumption they're all like sort of the same kind of firecracker. They have the same amount of gunpowder, and the brightness will be the same. Is that a good assumption? Well, maybe, maybe not. But that's what we have when you get to the farthest reaches of the galaxy. So for planets, we use radar. Nearby stars, we use parallax shift. Distant stars in our galaxy, we can use the RR Lyrae variable stars. For nearby galaxies, we can use the Cepheid variable stars. For more distant galaxies, the Tully-Fisher relation, compare galaxies to galaxies and use the inverse square law. And for the farthest reaches, we can use type 1 supernovae. I'm going to break up the lecture into two here, and we'll talk about galaxy clusters next time. Thanks for listening.